Okay, good evening. Welcome to
SuperMath167.
SuperMath167. So, just trying to do some movies tonight because we got a busy day tomorrow. So I thought since we're studying cylinders today,
Like the ant on the board today.
we have an ant on the board. Go away, ant. And we're studying cones tomorrow. And we've already talked about spheres a little bit. I'll be interested to see if you can remember. What's the formula for the volume of a cylinder?
It's pi r squared times height.
Okay.
Height.
So let's suppose the height's equal to the radius.
Alright.
Okay, what would the volume be?
It would be pi r cubed.
Okay, so if the height equals the radius, then we get pi times the radius cubed for a cylinder. Let's stick with this first. What do you think is the analogy to a cone?
Well, it's a cylinder, but where the top part of it is the top part. There's this circle has radius 0.
Okay.
So sort of it's pushed into a
Yeah. Does it remind you of anything we've studied already?
triangles, like triangles. Because if you have a square, you can sort of imagine drawing a line like that, and then you get a triangle.
Interesting. And is there a three-dimensional analogy to that?
Well, you have a cube, and then you can connect up the points on the top to make a pyramid.
Yeah, very good. What would you guess the volume formula for a cone is?
I would guess that it would be the same, pi r squared times height.
How come?
Well, the area of this is the same, and the height would be the same.
Mm-hmm.
But yeah, the volume is definitely less.
Yeah, it's definitely less.
But how much less?
Do you remember what it was for pyramids?
It was 1/3 base times height.
Okay.
So maybe it's that, because it's 1/3 the area of this. Because a cone is just a circular pyramid.
Yeah. That's what we're going to see. It's 1/3 base, pi r squared times height. That's what it's going to turn out to be.
And the height was the radius.
And so if the height's the radius, what's the volume of the cone?
It's 1/3 pi r cubed.
Now, we've talked about a sphere. Do you remember what the volume formula was for a sphere?
No. I think it had an r cubed in it.
Yeah, it's three-dimensional. It has a pi in it.
Was it like 4 pi r cubed over 6 or something?
Close. It's 4 pi r cubed over 3.
Oh.
4/3 pi r cubed. So the volume of a cylinder is pi r squared times height. The volume of a cone
Is 1/3 of that.
is 1/3 of that. And the volume of a sphere
Is
is
4/3
4/3.
of that.
Yeah. So, an interesting thing happens if we put a cylinder, a cone, and a sphere right next to each other. There's our cone, or our cylinder.
Yeah.
Here's our sphere. There's the radius. And then here's our cone. Okay.
Yeah.
Now, if these all have the same height, what's the height?
Well, we could say it's h. Actually, it would be 2r.
2r. So if we have the same radius and the height is 2r this time, pi r squared times height is 2 pi r cubed.
Yeah, these are just multiplied. These are all just multiplied by 2.
Yeah, here we would get 2/3
And then
pi r cubed.
8/3.
Gotta be careful, the radius of the sphere didn't change.
Oh, yeah. So that's the thing.
4/3 pi r cubed. Do you notice any interesting relationships? between those three numbers? 2 pi r cubed, 2/3 pi r cubed, and 4/3 pi r cubed?
Well, this plus this is this.
What does that mean about the volumes?
That means the volume of the sphere plus the volume of the cone equals the volume of the cylinder.
Pretty surprising.
Yeah, I think we watched something where the animation was they were all filled with, well, one of them was filled with, I think it was the cylinder was filled with water and it had like hoses running the sphere
Yeah.
and the cylinder, so they filled up halfway and then they were all halfway and then it emptied and these were all filled up.
You want to go see that now?
Alright.
So now you see where that's coming from. Alright, there, we found it.
It looks like it was 2 cones. Yeah, the cylinder. You can see it's twice. Interesting.
Pretty cool, right?
Yep.
So yeah, I guess you could do 2 half-size cones or 1
Full size.
full-size cone. Pretty cool.
Yep.
Alright, good job, Ben.